Understanding electrical codes requires a very specific approach, and that approach hinges on context. Without knowing the specific section of the code you are referencing, it's impossible to provide an accurate or meaningful explanation. Electrical codes, such as the National Electrical Code, or NEC, are complex documents that contain a multitude of rules and regulations covering a wide range of electrical installations. These codes are designed to ensure the safety of people and property by establishing minimum standards for electrical work. Imagine the NEC as a large, intricate puzzle. Each section addresses a particular aspect of electrical systems, and each rule within that section is a piece of that puzzle. To understand how a specific piece fits into the larger picture, you need to see the surrounding pieces. In other words, you need context. Consider a question about conductor ampacity. Conductor ampacity refers to the maximum current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables, such as Table 310.15b16, that list the ampacities of various types of conductors based on their size, insulation type, and insulation conditions. However, the allowable ampacity of a conductor can be affected by several factors, including the ambient temperature, the number of conductors bundled together, and the type of enclosure in which the conductors are installed. Without knowing these specific details, it's impossible to determine the correct ampacity for a given conductor. For example, if a question asks about the ampacity of a 12 American wire gauge copper conductor, the answer will vary depending on whether the conductor is installed in free air, in a conduit, or directly buried in the earth. The ambient temperature also plays a crucial role. If the ambient temperature is higher than 30 degrees Celsius, a correction factor must be applied to the ampacity listed in Table 310.15b16. Similarly, if more than 3 current-carrying conductors are bundled together in a raceway or a cable, a derating factor must be applied. These factors are outlined in NEC section 310.15c. Without knowing the specific installation conditions, it's impossible to provide an accurate answer. Another example involves grounding and bonding. Grounding and bonding are essential for electrical safety, as they help to prevent electric shock and fire hazards. The NEC contains numerous requirements for grounding and bonding, covering everything from grounding electrode systems to equipment grounding conductors. Suppose a question asks about the size of the equipment grounding conductor for a particular circuit. The answer will depend on the size of the overcurrent protective device protecting the circuit, as specified in NEC Table 250.122. The type of equipment being grounded also matters. For example, the grounding requirements for a separately derived system, such as a generator or transformer, are different from those for a standard branch circuit. Without knowing the specifics of the circuit and the equipment being grounded, it's impossible to provide the correct grounding requirements. Furthermore, consider the topic of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current. The NEC specifies the types and sizes of overcurrent protection devices that are permitted for different types of circuits and equipment. If a question asks about the correct size of a circuit breaker for a lighting circuit, the answer will depend on the ampacity of the conductors in the circuit, the type of lighting load, and any applicable voltage drop considerations. NEC section 210.19 outlines the requirements for branch circuit conductor sizing, while section 210.20 covers overcurrent protection. Without knowing these details, it's impossible to select the appropriate circuit breaker size. The NEC also addresses specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. These requirements often vary depending on the nature of the occupancy and the potential hazards involved. For instance, the grounding requirements for healthcare facility are more stringent than those for typical office building, due to the presence of sensitive medical equipment and the potential for patient contact with electrical devices. Similarly, the requirements for hazardous locations, such as areas where flammable materials are present, are much more detailed than those for non-hazardous locations. Without knowing the type of occupancy, it's difficult to determine which specific code requirements apply. In addition to the NEC, other standards and regulations may also apply to electrical installations depending on the jurisdiction. These may include local building codes, state electrical codes, and industry standards. For example, some jurisdictions may have adopted amendments to the NEC to address specific local conditions or concerns. It's important to be aware of all applicable requirements when designing and installing electrical systems. Therefore, when asking a question about electrical codes, it is essential to provide as much context as possible. This includes specifying the exact section of the code you are referring to, as well as any relevant details about the installation, such as the type of wiring, the size of the conductors, the type of equipment, and the occupancy of the building. The more information you provide, the better the chances of receiving an accurate and helpful answer. To summarize the key elements of providing sufficient context: firstly, specify the exact NEC section number or article you are asking about. Secondly, describe the specific situation or application you are dealing with. This includes the type of electrical system, the type of equipment involved, and the environmental conditions. Thirdly, provide any relevant measurements such as voltage, amperage, wattage, and conductor size. Fourthly, identify the type of occupancy, such as residential, commercial, or industrial. Fifthly, indicate the jurisdiction or location where the electrical installation is located, as local codes may vary. Without this information, it's like trying to solve a puzzle with missing pieces. The person answering the question can only guess at the intended meaning, which could lead to incorrect or even dangerous advice. Providing context is not just about getting the right answer, it's about ensuring safety and compliance. By providing the necessary information, you help to ensure that the advice you receive is accurate, relevant, and appropriate for your specific situation. Ultimately, this contributes to a safer and more reliable electrical system. Remember, electrical codes are complex and multifaceted. They are not designed to be interpreted in isolation. Context is the key to unlocking their meaning and applying them effectively. So, the next time you have a question about electrical codes, take the time to provide the necessary context. It will make all the difference in getting the right answer and ensuring the safety of your electrical installation. Without the specific section of text, any explanation would be speculative and potentially misleading. Therefore, please provide the relevant section so a proper explanation can be offered.